In this video 5.1, we're going to be looking at rate of change and slope. By the end of the video and work time in class, you should be able to say, I can find rate of change, and also I can find slope. Rate of change shows the relationship between two changing quantities. When one quantity depends on the other, the following is true. Where you have rate of change is your change in the dependent variable divided by the change in the independent variable. In an example here, it says the table shows the elevation of a hang glider over time. Is the rate of change in elevation with respect to time constant? What does that rate of change represent? So we see that the time is constantly increasing by 1. So this is constant. So we look over here, it's constantly going down 35. So negative 35 would be that common difference. And so it is constant, so yes. And then what does that rate of change represent? It represents the hang glider is descending at a rate of 35 feet per minute. Slope is the rate of change, and slope is your vertical change divided by horizontal change. A lot of times we look at rise over run. So if we look here, I plotted the points from the previous slide on the hang glider at the different times in the elevation as it's descending 35 feet per minute. We can see at these points, if I look going from left to right, I also see the lines going down, so it's a negative slope. I see that I'm going down 35 over 1, down 35 over 1, down 35 over 1. So this is our rise, which is down 35, so it's negative, and then our run is 1 because it's going to the right, so it's positive. And it continues negative 35 over 1, and negative 35 over 1. And that's how we see our rise over our run, that our slope here is a negative 35. Once again, if your points are going downward from left to right, that's going to give you a negative slope. So here we're going to find the slope of this line. I'm going to just highlight with a different color here. I'm going to use red. Highlight the different points. And we're going to figure out the rise over the run to figure out the slope of this line. So we're looking at rise over run. It's going upward from left to right, so it's a positive slope. Rise 1, run 4. Rise 1, run 4. Rise 1, run 4. It's constant. It's a linear function. Rise 1 is positive 1. Run 4 to the right, positive 4. Rise 1, run 4. Rise 1, run 4, 1 and 4. So the rise is 1, the run is 4, so the slope is 1/4. I also want to show you if I was going backwards from the right side over here, down 1, left 4, down 1, left 4, down 1, left 4, down 1, left 4. What happens here is I'd have negative 1 because it's down 1, and then left 4 would be negative 4. Negative 1, negative 4. Negative 1, negative 4. Negative 1, negative 4. Now what happens here is your rise would be negative 1, your run would be negative 4, which we know ends up being a positive 1/4. So we could look at it that way too. A negative over a negative gives you that positive slope of 1/4. Looking at this line, we see it's going downward from left to right, so we know that it has a negative slope. We're going to highlight once again some points that we see land right at the intersections on our graph paper. You want whole numbers. Okay, down 1, right 2, down 1, right 2, 1, 2, 1, 2, 1, 2. You see the steps that's created here. Okay, so down 1, that's negative 1, right 2, that's 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Okay, so for rise over run, to find our slope, our rise is negative 1, our run is 2, the slope is negative 1/2. If I looked at it going the other direction, 1, 2, 1, 2, 1, 2, I'm just going to stop here. 1, negative 2, 1, negative 2, 1, negative 2. The rise 1, the run negative 2. That's the same thing. This is negative 1/2. It's just the negatives in front of the 2. It doesn't matter, but it's the same thing as what I have written in red. The negative can be in front of the numerator or denominator or just in front of the whole rational number to represent that it has a negative slope. The slope formula is that slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. What happens is if you have 2 points that fall on a line, you can use those 2 points to find the slope. Where we know a point is when we have an ordered pair x, y. And so if we have 2 points, the reason these sub numbers just say, okay, oh, actually, that was not right. Take that back. This is like 1 point, and this is another point. The sub numbers just are representing different points. So you need 2 points on a graph to use this formula. So if we, it says, what is the slope of the line that goes through negative 3, 2, so right here, and 1, 5, right here. I can graph it and figure out my slope, which we're going to in a minute, but I also know using that formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my y sub 2, the y is the second number. I'm going to say this is my y sub 2. So if this is my y sub 2 here, which is 5, minus my y sub 1, which would be the 2, divided by x sub 2. Now if I said the 5 is the y sub 2, then the 1 has to be the x sub 2, minus the x sub 1, which is negative 3. That becomes plus 5 minus 2 gives me 3. 1 plus 3 gives me 4. The slope is 3/4. It's positive. I can also see if I were to connect these points that I graphed, because I graphed the 2 points, rise 3, run 4, I can see the slope is 3/4 there too. So there's 2 different ways here. You can see it with the step in the picture, rise over run. You can also use the slope formula to find 3/4 as well. What is the slope of the line here? You can see it's a vertical line going through 3. So what we do is we're going to use the formula y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. I'm going to highlight 2 points. I'm going to highlight 0, 0, and let's say, or I'm sorry, not 0, 0. I'm highlighting 3, 0, and let's say 3, 2. We'll highlight those 2 points. Okay, so what we would do here is I'm going to write these out here. So we've got 3, oh, I don't know why it did that. So the 2 points I have highlighted are 3, 0, and I also have 3, 2 highlighted. So I'm going to use the formula to find the slope. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. 2 minus 0 is 2. 3 minus 3 is 0. Now when we see this, where we have a number divided by 0, we know we can't divide something by nothing. This is undefined. So it does not have a slope. It's undefined because you can't divide by 0. So vertical lines have an undefined slope. There's no rate of change. With a horizontal line, I'm going to pick, let's see, 2 points, 0, -2, and 2, -2, using the formula y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And so my 2 points I'm using here are 0, -2, and 2, -2. I'm going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. -2 plus 2 gives me 0, divided by 2 minus 0, which is 2. And so our slope here is 0, because 0 divided by any number is going to give you 0. And by the way, any horizontal line is going to give you a slope of 0. So, just a quick sketch of all the different slopes. If it's going upward from left to right, this is positive. If it's going down from left to right, this is a negative slope. If it is a vertical line, these are just sketches, it's not perfect, this would be undefined. And if it's a horizontal line, which ignore that, something's wrong with the smartboard, horizontal line, you're always going to have a slope of 0. Can you say I can find rate of change and I can find slope? Write a summary and reflection and be prepared for the work time in class.